All right. So now let's start from 63. Right, and of course, the reason why is, see that these two problems are the same, so let's just try one, for the whole class. Then if you want, you can try the 62 later in your spare time. Yeah, well, that's all right. Well, you're gonna do great in physics, I think. Huh? All right, guys, let's take a look at 63. So the amplitude is 20. Well, that's why you see that. Well, unfortunately, there are three options, right, that has the amplitude 20. Now, does that negative sign bother you guys? If they say amplitude is 20, but somehow some of the options has negative 20 in it? Good. Amplitude is just the absolute value, right? It's just the absolute value of the coefficient, right? Just the positive distance, right? Now, what I suggest that you guys work out the period, or remember the period formula is 2 pi over the b, right? The value of the b, which is the number in front of the variable, right? So in this case, we want the period to be 3 pi. You see that the b has to be 2/3 to make it work, right? Just solving for the b, right, from this equation. Now, once you see that the b is 2/3, and that leaves you only one option. But the question is, it's not supposed to be like that. So a good multiple choice will still leave you two options, right? Because if you want to do a little thing, you might left with letter B and D, right? Then you have to figure out whichever is correct using some other information, right? Okay, that's a good question. So now let's make the option B a bit more confusing. Well, I'm only doing it in a test review, so I'm not intention making the test, like a more confusing. It's whatever questions in the question bank, I pick from them. So if you don't like the questions, hate them. All right, so it's not me because they make the question like that. Now, what if I change the letter B into -20 sine 2/3 of t? So now you see that the B and D are so close, right? The only difference is sine and cosine. How do I know that cosine is correct, not the sine? And now, this is, the part I don't like those, textbook questions. Say it again. Yeah. Yeah, and also, who realized that when they say the object is pulled down, that means it's in a negative position to start with, then released, and that's actually make a difference. So now let me show you the animation here. It could be sine or cosine because it's just changing, right? So now this is the object they're talking about, right? They're moving up and down above or sometimes below the rest position. They say that to start the motion of like a certain marble, you could pull it down and let go, right? You could also lift it and drop it. But they say stretch it, hold it down, start from somewhere below the rest position and let go. And let's see what it says about the function you're supposed to deal with. Now, here's what you can do. If you think that D might be right, or letter B, right? So please evaluate this position D at t equal to 0. You get -20, right, times cosine. Well, 2/3 times 0 is still going to be 0, right? So in this case, it's either 0 degrees, 0 radius. They're the same, right? So at least that if it's 0, that the degrees and radians doesn't make any difference. But how much is cosine 0? Some say 1. Just remember it. That was a good guess. It is 1. But don't do that in a test, all right? use the calculator. Right? Type in cosine 0 and you see it's 1. That means this is negative 20. Does it make sense that the object starts from negative 20 if it was pulled down and released? Because it's somewhere below the reference position, right? So now what about letter B? If you do the same thing, evaluate the position at equal to 0, you get negative 20 times sine 0. How much is sine 0? Then calculus is going to tell you it's a 0. Sine 0 is 0, right? That means you get 0. Well, that doesn't make sense because the object has to be pulled down and start somewhere below the rest position. Okay? Okay. All right. You're welcome. All right. All right. Now, let's take a look at 65. So you go the other way around, right? Try to identify period, frequency, and for some reason, they want us to find the maximum displacement, but they only put displacement in the option. So I'm not a big fan of they being that kind of sloppy with the terminology because displacement is not the same as maximum displacement. Right. But I think I understand that they're actually asking for the max displacement. Now, your best bet will be the period, right? Since you can see the period in this case must be 2 pi, right, divided by whatever number in front of the t, right? It would be 3 pi on the denominator. It works out. It's the same as before, right? 2/3. So that can filter through the options, right? And you are eliminating letter A, right? That's just wrong. And also letter C, right? So now you're looking at B and D. You hope that the frequency is going to tell you, right? So that you don't have to worry about the displacement. Frequency is the reciprocal of the period. That'll be 3/2. Oops. But unfortunately, letter B and D have the same exact frequency. Okay. So now you have to figure out what they mean by maximum displacement. So I believe that I mentioned in the class last week, maximum displacement is nothing but the amplitude. Amplitude. Even though it might not be the case in physics, but somehow that they define the so-called maximum displacement in their own way. Because obviously this, professor, I think this Blitzer, this guy is a math professor for Miami-Dade College. So he was using some physical, scenario to illustrate the math, and turns out that he misunderstood the concept. Anyway, but you be safe. You understand that maximum displacement is amplitude, and that's why it has to be positive, right? But that's not the issue here because, phi and A are positive, right? So what makes A wrong, right? Phi has to be the correct answer. So now you have to think about. Oh yeah, Max, go ahead.
So the +3 doesn't matter.
For this problem, it doesn't matter because they're asking for maximum displacement. But let me show you when it does matter. Okay. All right. So now let's say if you're observing those, oscillation of those marbles, right? So if the rest position is 3 meters above the ground, so all those marbles are going up and down about that reference, the rest position. But the amplitude for every marble is 2 meters. That means it can go as high as 2 meters above or 2 meters below. So when they say the maximum displacement is by design the distance between the marble and the rest position. That means you just lift it, stretch it, right? So you're gonna go up and down about the same, position, right? So therefore, if the amplitude is 2, the maximum displacement is 2, right? No doubt. But if I ask this guy, what is the maximum position of this marble? Guess what it'd be? The max position will be is it 3 meters? Right, I said 3 meters. Yeah, 3 meters plus 2 meters. That's how high the marble can get relative to the sky, right? And that's what we call position, right? So this is like, you know, I might say, well, where do you live? You say, well, I live maybe to the north, like 10 miles away from the school. That's a displacement. That's you're measuring your home location relative to school, right? But who's going to tell you, you know, my home location is the whatever latitude, whatever longitude. Like you're telling me the GPS coordinates. I mean, you're not wrong, right? But, you know, who cares, right? So that's because there's no way I can tell where it is, right? I have to look it up. But when you tell me it's the relative direction distance, oh, that makes a lot of sense. But it depends on how they ask you. If they say the maximum position, that's the absolute position, right? How high it is, right? Above the ground level, let's say. So you're going to have to figure it out. If you do need to add that 3, which is the initial shift, right? The vertical shift to the displacement or not. But if you're saying that, hey, what is the displacement? What is the maximum displacement? The maximum displacement is as simple as the amplitude, okay? But I don't think that they ever ask you the position in the question bank. So that's all I know. That's right. Mhm. Yeah, it's like, you know, instead of asking you, hey, what is your score? I ask you, hey, what is your ranking in a class, right? You say, oh, I got, I was, you know, like, you know, in a senior class, right? I'm the top 5, right? I mean, top 5 of CA, right? Not necessarily top 5 of Florida, right? But if you have like 1600 SAT, well, you're not necessarily, you know, the top, right? Because there are still other people getting 1600, right? But that pretty much places you at the very top, right? So it's like, is it relative or is it absolute? Anyway, now, oh, there are 2 more. And let me do 67. I don't know why. It's ever since then, this becomes a very frequent number. Yeah. You know, there might be some mysterious things. Oh, you know what? I heard that 42 is also a very mysterious number. Go look it up. You know, there are a lot of people on the internet saying that 42 is a mysterious number. It says something about the truth of the universe. Go ahead, search on YouTube or internet, or ask AI. Right? Why 42 is so special? I didn't lie. You know, I learned it a couple decades ago. Anyway, see that? Yeah. Anyway, now, they say that now, let's say a weight is attached to the spring and it's pulled down. Again, it's pulled down by 3 inches. Now the frequency is 7 over pi. Figure out which equation that describes this kind of motion. So again, you know, I will prefer to work out the period first, right? But who can tell me if the frequency is 7 over pi, what is the period? Pi over 7, right? Just flipping it. But you know, it has to be 2 pi over b, right? We need to know the b value to tell which function is right. So now you're solving for the b, right? However you want to do it, maybe cross multiplication, or rearrange the terms, right? But I hope that you see that pi's cancel and b will work out as 14, right? So now you rule out b, you rule out c and a d, but unfortunately you have the a and a b and they're so close. Then should you pick a negative number in front of the cosine of a positive number? Max. Why is it negative? It's pulled down, right? And again, you know, the reason why it pulled down and gets you negative is because you take the t to be 0, right? The initial moment, and realize that cosine 0 is 1. right? You're gonna get negative 3. It's the negative initial position, right? That means if I were to change the question, I won't. I'm saying that if there's a question said that the object was lifted, right, 3 inches above the equilibrium position, then released, then you'll be looking at letter B. Okay, so the initial position does make a difference. All right, moving on to moving backwards, right? So I think that the bearing is not bad at all, or if you just want to find out what the bearing angle is, right? So I'll do 57 real quick. So OB is that desired direction. You can see that it's obviously closer to the north, right, than it is to the south. Therefore, I need to specify the angle between the north and OB, which, as you can see, that's just the complementary of the 49, right? It'll be 41 degree in between the north and OB. And the bearing will be north, right? Since, it's closer to the north, you start from the north, 41 degree, and you turn into the west. That's all. Okay. So the previous class asked me how many questions on average for each topic, since go from 5.5 to 5.8, right? Now I have to let you know, since there are not many good questions are designed for FRQ, but turns out that 5.8 has more application problems, right? So more word problems. So I'll say that if it's FRQ, you should definitely prepare yourself for a question or multiple question from 5.8. But when it comes to the multiple choices, since there's only 10 questions, right? We have 4 topics. I mean, there will be 2, 3 questions for each, topic. Now, if you do have that worksheet for the right triangle thing, do you guys have it? Yeah, can I use it real quick? Well, think about if these kind of questions could be a good idea for a multiple choice or an FRQ. FRQ, right? So if I pick this as FRQ, then I don't want to waste a multiple choice to do the same thing again, right? So now I left with only 2 questions, then I'm allowed to have for 5.8 for the multiple choices. So there are only 3 topics, right? In 5.8, solving for right triangle, this is going to be a FRQ, right? Potentially. Yeah, I mean, it's true, right? So you may or may not see a question like that. And the bearing thing, and also the oscillation stuff, right? So it's gonna be 1, for each, right? Most likely, just take a guess, right? All right, thank you. Now, but what if you have those, like a harder version of the bearing question? And if you remember that we did 61, right? That was quite tricky, and it turns out that they provide you that S 57 West, South 57 West, just for distraction, right? But we did that, right? Last Wednesday or Thursday, I forgot. I'm gonna do 59. And it's always worth drawing a sketch to make sure that you're understanding the scenario correctly. All right, this is north, east, southwest. So the boat starts from the origin or the harbor, and it travels 16 miles north, 38 degree east. So it'll be in this direction, right? Start from the north, right? Turn to the east. All right, so this angle is 38 degree. So the distance from O to the point A is 16 miles. And that's pretty much it, right? But the question might be a bit confusing. Like, what does it mean? Like, how many miles north? And how many miles east? from the harbor. Well, the object or the boat, right, is not strictly to the north or east, sort of in a northeast kind of direction. But if you want to know, like, if it's worth strictly to the north or east, you need to imagine like projecting the point onto the eastward direction. Let's say this is a point B, and projecting A to the northward direction, and that's a point C, right? You form a rectangle, right, with two congruent triangles, right, two right triangles. And it turns out that the distance from O to B is what they mean by the distance, right, in miles to the east of the harbor, right? And OC is the distance in miles, right, to the north. Therefore, you're just finding what is OB, right, and OC. So now we have transformed this word problem into a geometry plus right angle trig kind of problem. So the way it works is make sure that you pay attention to the right triangles. So say that in the right triangle OAC, if I'm looking for OC, that's the adjacent side of the angle, right, 38. So I'll say cosine 38 degree must be adjacent OC over hypotenuse OA, right? Therefore, OC is OA times cosine 38, right? And make sure that you have your calculator and you know that you're in degree mode. Otherwise, you're gonna have the answers way off. But it's good, you know, it's multiple choices, right? If you do get something that doesn't even match at all, that means you're probably in a different mode, right? Anyway, so if you work it out, that will be the number of miles of the boat to the north, right, of the harbor. And you do the same thing for the OB, but you do realize that in OBAC, that's a rectangle, right? That means if you're trying to find OB, it's nothing but AC. Okay. Now, if you're finding, in this case, the opposite of angle 38, but you already figured out the adjacent, right? I think that you could figure it out. It's nothing but the hypotenuse times, instead of a cosine, the sine of 38, right? And you work out, again, the miles to the east, right, of the harbor. All right, so let me zoom out a little bit. Do you have any questions about this one? Good question. So it depends on if you're solving for the adjacent side or the opposite side of an angle. You see that here in this right triangle OAC, I have the hypotenuse, right? I'm looking for OC for some reason, but OC is the adjacent of the angle 38. The adjacent, right, is well, the cosine that relates the adjacent and the hypotenuse. That's why you're going to be using the cosine. And the opposite is going to come from the sine. All right, let's move on. Now, if you were to ask me for the OneNotes thing, I'll send you the PDF. Also, you can watch the recording. Now, for these three problems, I think that you probably remember from maybe 5.3, 5.4 when we do the test review. There's some problems are just like that. So we could do 54 real quick, since that's the problem that has the inverse function involved. All right. So they say that you have a building which is 300 feet tall, and a guy standing on the top of the building. Right, and the top of the building is casting the shadow on the ground level, and the shadow is 60 feet long. So they want to know when the guy looked down at the tip of the shadow of the building, right? What kind of angle does that make from the vertical direction? Right. So basically, they're looking for the angle of theta. Well, so you realize we have tangent theta equals the opposite, which is 60, right, over the adjacent 300. To find the theta, you're going to use the inverse tangent and feed it with the same ratio and get the angle. In this case, in degree. Okay, that's all. So for these kind of a real world situation kind of word problem, feel free to try 58, 56. You'll see that they are very doable. Okay. Yeah, go ahead. All right. You use inverse trig, inverse tan, inverse cosine, inverse sine to find the angle, to find how much the angle it is. Yeah. But if you're only using the regular trig functions, you're getting the size of a triangle. Okay. That's like an opposite, adjacent, hypotenuse, like what we just did, right? We're looking for the adjacent, right? We're using the cosine, but inverse is going to get you the angles. Now, these 4 questions, I think that we did something very similar to those kind of questions on the 12th and 18th. So again, watch the recording if you want. But they will be talking about the same problem with different numbers, right? But I think that you should definitely be able to learn from, the problem itself, not just the numbers, right? But there are 2 situations, right? You can probably tell. So like a 4950, they are talking about a given angle, right? And a side. Okay. So in that case, you can find out the other missing acute angle, right? Almost without any effort, and find out the 2 missing sides using sine, cosine, tangent, however you want, right? So that's like more intuitive. But 51 to 53, they provide you 2 sides without any angles. So for that, you have to use the inverse trig to first get yourself an angle, right? Like here in 51, the B is 140, C is 480. I mean, of course, you can find out A, right, using the Pythagorean theorem. But if you ever want to find the angle A, given the adjacent of angle A and the hypotenuse, so A is going to be the cosine inverse, right? Why is it cosine inverse? Because cosine inverse gets you the angle, right? But why is it cosine inverse, not sine inverse? Because we have the adjacent and hypotenuse, right? Again, I'm going to skip that kind of questions, so feel free to look them up from a prior lesson recording. All right. Now this is actually the kind of a challenging questions. Even though that they don't really they're not going to be worth any more points than other easy questions, right? But I think that it could be pretty frustrating if you are not prepared for that kind of question before the test. So I did say no calculators, but I'm not saying that you're not supposed to use calculator in the test. I'm saying that you're only going to get a point for the right answer if it's a multiple choice, if it's a FRQ. So you do have to learn the right way, like as if that you don't have a calculator, how would you work it out? Okay. But by all means, you have access to calculator for the whole test. Use it however you want, to assist yourself to get at least an answer and go from there. right? But let me do 31. I think that I did that before, maybe, you know, not necessarily with the same angle, right? 4 pi over 5. But I think that I did something very similar. Hopefully, I'll help you to recall what we did with the terminal side, right? And a reference angle kind of thing. Then I'll show you maybe a slightly different way, just in case you might be open to, you know, different methods and you might like one over the other. So we are looking for how much is sine inverse of sine of 4 pi over 5, right? But what will be your initial guess? What will you wish it's going to be? You see a sine inverse and a sine. Those are inverse function of each other, right? Would you say that you kind of hope that it will just work out as 4 pi over 5, right? That would be kind of nice, right? But unfortunately, 4 pi over 5 is wrong. And the reason why it's wrong is sine inverse has a range, right? From negative pi over 2 to pi over 2. But this is beyond the range of sine inverse. Therefore, our goal is to find another angle, like alternative angle. And it works out somehow sine theta prime is the same as sine 4 pi over 5. But I want that theta prime falls into the range of pi over negative pi over 2 to pi over 2. Right? I believe that it's very straightforward for you guys to get to this step. Right? And please show me that in the test. You know, if it's FRQ, then you know you most likely will get a point. But the hard part is how do you find an angle like that? And I hope you realize that I call the angle theta prime for a reason. So the way I showed you like a week or maybe 2 weeks ago in class, it's like plotting the angle 4 pi over 5, right? Which, as you know, is in the second quadrant, right? This is for 4 pi over 5. And I said to think about how this angle is related to the value of the sine function, pick a point on a terminal side, and realize sine function is defined as y, right? Back in the unit circle definition. You guys remember that, right? Sine is y, cosine is x, right? Tangent is x, y over x. That means I'm just looking for another terminal side that has the same exact y value if you were to pick a point on the terminal side. Where can I draw the terminal side? I cannot draw it over here, right? Because the y is going to be negative. I cannot do it over here, right? The only quadrant I can think will be over here, right? Or I should have done a different color. All right, so basically I decided to draw this blue terminal side as if that it's the red one reflected off by the y-axis. Okay, that will make sure that they are at the same exact vertical level, right? So that the y here, right, will be the same as the y over there. So now the question is, how much is this angle? And that's what we call theta prime. But long story short, if you could realize, since the graph is exactly symmetric left and right, this angle should be identical to the angle right over there, right? And that's the supplementary angle of 4 pi over 5. And how much is supplementary angle of 4 pi over 5? It must be pi minus 4 pi over 5, right? It will be pi over 5. But quite a few students realize, oh, isn't that just the reference angle of 4 pi over 5? Yes, that's why we call it theta prime. But it does not always work out as a reference angle. It will be close, but not exactly always the reference angle. So that's what we did, right? A couple weeks ago. So now let's see if you're gonna like maybe a slightly different way. Or let's say this is method number 1. Method number 2. Now you're gonna get yourself a formula in the second method. Hopefully that's probably better than thinking about geometry. But you guys need to tell me, what is the midpoint formula? You guys remember it? That's the distance formula. Right. So let's say on the number axis, right? On the number axis, you have 2 coordinates, x1, x2. If I want to find the midpoint M, what would it be, right? But I'm sure that you can see that M must be like, as she said, x1 plus x2 over 2, right? Does that make sense? Just average. But now I want to invert it. If I know what the midpoint is, and I know one of the coordinates, I don't know the other coordinate. Say, what is x1? You just invert it, right? You get 2m minus x2. Does it make sense? And that's the formula you're going to use for finding the theta prime. All right, let me show you how. Again, you're going to have to plot that angle, right? But instead of plotting it in a circle kind of thing, you plot the sine graph. But you have to be able to plot it. It's not just for this problem. So if you are not able to confidently plot the sine and cosine graph, you need to look up these, graphs. I have a cheat sheet for you guys, right? Like maybe, no. Don't spoil your brain. So now I'm not asking you to draw the complicated ones. It's just sine of x. So it'll be 0 here. This is pi over 2. That's pi, right? This is 3 pi over 2. That's 2 pi. And here, this is negative pi over 2, right? Usually you don't need the negative portion, but I'm just drawing it, just for, just make it prettier. Negative pi. What do we want? We want an angle. Okay, so we want sine theta prime to be the same as sine 4 pi over 5, right? So you guys know where 4 pi over 5 is on the number line? Where should be 4 pi over 5 located? It's less than pi, actually. You see that? Right, so it'll be somewhere here, right? So this is angle theta, right? That is 4 pi over 5. So I want another angle that has the same exact function value. So if I'm going to go up to the sine curve, right? And I find out this is the sine function value I want. And let me draw a horizontal line. And do you see that it will intersect the sine curve at here and many other points, right? But let me make this point a little bit bigger, because that's the point that's going to tell you what theta prime is. But what makes this point so special? Do you see that this point is the only point that falls into the restricted domain of the sine? Restricted domain from negative pi over 2 to pi over 2, because that's the point you want, right? If I scroll up, you see that theta prime needs to be in between negative pi over 2 and pi over 2, right? So now take a close look at theta prime and theta, see where they're located. And also, do you realize that pi over 2 happens to be the midpoint? How do you find theta prime? Using that midpoint formula I just told you. Isn't that just theta prime equals 2 times the midpoint, so 2 times the midpoint, which is pi over 2, minus the other angle, which is 4 pi over 5. If you work it out, be pi over 5. That's all. I guarantee it works, but you need to get it ready. What do you need for this formula? You need to know what the midpoint is. If you didn't draw, how would you know that pi over 2 is the midpoint? You also need to know what the angle is, but that's telling you the angle didn't work out. That's the angle you want to use, right, to find out its alternative, right? So you draw in the graph to visualize what you can use for this formula. And with the formula, I think that you can simply rely on the algebra to figure out what the angle is instead of using the geometry if you're kind of, not a big fan of geometry. Again, that's the second method. If I scroll down a little bit. All right, so I guess I'm gonna stop. I'll continue next time. So what you can do to make the tomorrow session, even smoother is to try question 31 to 37 on the second packet. I did the 31 already. What do you want? So I'll come back if you need to take a picture. So I'm saying that, do you see that I picked the question from 31 to 37, right? So try all 7 or as many as you can before come to me tomorrow, right? And we'll go over that. I will make sure that, there are actually 3 methods. I don't know if you realize, right? The reference angle, like that's a lucky guess, for this kind of question, but not that lucky actually. Then the terminal side thing, right? And also we have the sine graph kind of thing, right? Whichever you like. Unfortunately, I don't have a 4th one right off the back. So you kind of have to pick one or figure out a way on your own to convince me that you get this right, appropriately. But try those questions before you come to me, then, you benefit more from our discussion.